Section 2.2 has to do with linear functions, something that you are already very familiar with. So every time you graphed a line or wrote equations of lines in algebra, you were dealing with linear functions. And so part of this unit is to be able to identify whether something is a linear function or not. Something else we're going to be doing is writing linear equations in standard form, and I'll show you what that is, and then graphing linear equations using their intercepts. So linear functions were just one type of parent function that we focused on when we talked about transformations, but we're going to get into more details with linear functions here today. So first it says linear functions are functions that can be written in the format ax plus by equals c, and this is standard form. We're also used to seeing slope-intercept form, and so that's not the only way to write a linear equation. If you want to think of it as y equals mx plus b form, that's another format that will consistently be linear. And so, for example, if the x and the y are not being taken to a power, as they are here, so this is nonlinear, if they're not being multiplied together, as they are here, and you're not dividing by a variable, as it is here, then it's going to be a linear function. And so the reason that this is nonlinear is because of the squared. Here, the square root part is the issue. Here, it's because we're multiplying the x times the y, and here it's because we're dividing by x. All of those are the reasons why they are not linear equations. So let's take a look at example number 1 here. It says state whether g at x equals 2x minus 5 is a linear function. Write yes or no and explain. And so in this case, this function is in slope-intercept form. My slope is 2, my y-intercept is negative 5. So I'm going to say yes, this is a linear function. And I'm going to say because it is written in slope-intercept form. Slope-intercept form is always linear. In slope-intercept form. For example number 2, it says state whether p at x equals x to the third power plus 2 is a linear function. Here this third power is the issue. So I would say no, not linear, because of the x to the third. It's a cubic function, not a linear function. Now, part of what we're going to do for graphing linear equations is graphing by the intercepts. And so there's certainly an x and a y-intercept on a linear function. But when a graph is in standard form, which is the format we were talking about above, that ax plus by equals c, it's often easiest to graph it based off its intercepts. Because when we talk about intercepts, we are simply plugging in 0. So plug in 0 for x to find the y-intercept. So if I plug in 0 for x, I get this whole term to go away, and I get 3y equals 12. Well, then I'm going to get the ordered pair 0, 4. Divide both sides by 3. If I plug in 0 for y, that's the something comma 0. So I'm plugging in 0 for y. My x-intercept is going to be 4x equals 12. If I divide both sides by 4, I get 3. And so then I just simply graph both of those points to solve the problem. So let's do example number 5 here. It says find the x and y intercepts of the graph, and they give us the equation, and they ask us to graph the equation. This is not quite in standard form, so what I'm going to do is move this minus 4 to the other side. I'm going to rewrite this as negative 2x plus y equals a positive 4, because I added 4 on both sides. So to find the x-intercept, I'm going to plug in 0 for y. So if I plug in 0 here, negative 2 times what gives me 4? Well, that's a negative 2. And to get a y-intercept, I plug in 0 for x. And when I do that, I get y equals 4, which is y equals 4. And then I can graph that information. So a lot of that work I'm doing mentally. So I get negative 2, 0 is the x-intercept right here. And 0, 4 is my y-intercept right here. And then I can just connect my dots because it's a linear function. So we're plugging in the 0. Plugged in 0 for y to get the x, plugged in 0 for x to get the y. Make sure you always write your intercept as a point. Go ahead and flip to the back. Example number 6. Here it says they want us to find the x and y intercept of this graph. And so I'm again going to move this 6 to the other side so it's in standard form. I'm going to rewrite this as 3x minus y equals negative 6. For the x-intercept, I plug in 0 for y. So when I plug in 0, I get 3x equals negative 6. If I divide both sides by 3, I get negative 2. I can go ahead and graph that, negative 2, 0. And then for the y-intercept, if I plug in 0, I get negative y equals negative 6. Divide both sides by negative 1, and I get 0, 6. 0, 6, we'll put this right here. And I would again connect it up. So when you talk about an x and y intercept, you need to make sure that it's an ordered pair. When the y value on this graph is 0, the value that for x is negative 2. By contrast, when the x value is 0, the y value is 6. And so that's going to help us as we get into some word problems and discussing what intercepts mean in some application problems in class.